Hey, anybody? I'm not sure if anyone's here yet. I'm going to start up in a couple minutes for the Tech Chat Tuesday. That's what we've come up with for our newest name of this continually renamed podcast. Screencast, video, stream, whatever the heck I'm doing here. Last week, we had a really good talk about the WWDC with Steve Smith and Don Coleman of Chariot Solutions. This week, because it's kind of a week just before the holidays, I want to have an excuse to do something. And so my goal was to put something out. And our marketing person, Tracy Wilson-Rossman, asked, is anyone going to talk about Java's 25th year? And since I'm 51 and I started with Java when it was tiny, a little wee child, and learned it about 23 probably years ago, maybe a little less, I wanted to put out an episode to talk through it. It's been a mainstay of my life as a developer for more than 2 decades. And actually, minus the JavaScript front end stuff I've been doing over the last couple of years, it's been basically taking over. So we're going to start up in a couple minutes and talk about that. I'm assuming that no one's going to be on this thing because it's an odd week and I didn't really push it that hard. So most likely you're watching this as a replay, and that's perfectly fine. I have some silly things that I have planned here in the talk. And so, stick around till the end. We're going to try to keep it. We have to keep it under an hour. I've got things to do in the afternoon. But, we're going to launch in and talk about Java being 25. So, okay, I'm just going to kind of get started with some preamble here. The big topic guess is Java is 25. There's my little really high-end graphic there. See that? It's cool stuff, right? But Java is 25 this year, and that's a big milestone for Java. Of course, you could argue that Lisp is like 60 plus years old, and sure, you could say that a lot of other languages have stood the test of time. People are still writing things in COBOL. As we found, it's being used for payrolls in New Jersey. So certainly, that is something that is a topic of interest beyond Java itself. But since this has been most of my adult career, from the time where I was an overly confident 20-some-year-old thinking I knew everything till now, where I'm less and less confident about what I know because I know there's so much more to know. This is my take on the Java language and what it meant to me, and just talking about the history of Java. Before we start, make sure that you go ahead and subscribe to that. Click the little subscribe link at the bottom of the video, and click the bell to be notified when new episodes come out. We're going to try to do these every Tuesday, and we're going to have a whole bunch of different variety of topics. This is going to be my primary outlet for what used to be the Chariot TechCast podcast stream. It will still come out on that podcast stream, but it also is going to come out here as a live broadcast. And so I'm glad you're joining me either later or right now. Leave comments if you want to talk about things. I'd be more than happy to talk to you about what comes up. So let's start off. Let's talk about Java's history a little bit. When it was first created, there were 3 people at least involved. James Gosling, who's kind of the father of Java, Mike Sheridan, and not to be related to our Mike Sheridan at Chariot, and Patrick Naughton. And it was started in 1991. And the original goal for Java, interestingly, was interactive television. Now, if you can think back, if you're a developer old enough to do this experiment, think back to 1991 and what the technology was that was out there in 91. I had just gotten out of school a year and a half before, probably. And so, for me, I was just experimenting with Slip and PPP and the original browsers and Gopher and Usenet groups and all of that. So the internet wasn't the internet we know of today. People didn't have Wi-Fi yet. That was yet to come. And so, the network was not really a network for consumers yet. It was just more people would connect up with their dial-up provider to get on the internet, and then eventually DSL and so on. But it was more of a hobbyist's platform. This is before e-commerce. So for them to think interactive TV was something that was going to be immediately useful, that was really, really forward thinking. And if we look at the history of Java and the history of Sun Microsystems, it is a lot of those things, right? They were very, very ahead of the curve in the ideas of the technology before the realistic implementations of that technology could really take off because of enablement through faster CPU speeds and faster hardware and faster networking, better graphics, better resolution, and things like phones that have, things like Java, or in this case, Objective-C and other things in them. So it started off as a language called Oak. And the reason, I didn't know this until I looked today, the reason it was called Oak, and you'd think I'd know this, was because James Gosling had a big oak tree outside of his window. So there's the reason it was called Oak. Spent a little bit of time as a language called Green, and then ultimately they picked Java. They were looking at, the Java coffee from Jakarta, from Indonesia, and so they called it Java. And certainly if you look at the language and the features, there are a lot of things that they used in this coffee metaphor, like Java beans and, jars of Java for archives and things like that. And so, certainly that is something that that kind of follows it in from its history. Interestingly enough, the one thing that I remember about Java being funny is one of my clients, when I was doing consulting independently, actually I was working for another company, and one of my clients came up and said, what's with all the coffee references to one of us? And we kind of chuckled because we were the nerds that knew everything, we're young and confident, but it's true. There were a lot of crazy coffee references, and it didn't make much sense to outsiders. It was kind of like inside humor, so to speak. So Java itself started off, they thought that they could use it as a hardware platform and language platform for hardware that was for TV sets, but it really didn't take off. So they purposed it then for the nascent browser industry as Netscape was coming up. We were having all these slow builds of browsers that were supporting client-side languages. And at the time, actually, Java and JavaScript were kind of competing with each other. Java had this platform called applets. I'm going to remind you of what applets are because it's kind of humorous to look at them today. But applets are a running in the browser virtual machine, which is pretty forward thinking for the time. Let me see if I can bring up a browser here with Java applets. The user interface was pretty bad. These were definitely thought up by engineers. The engineers who did the user interface stuff, this is way before CSS took off and styling really took its root in web-based applications. As I turn off everything, it's stinging me. It was very primitive user interface wise. There were things like TK and TCL and other user interface toolkits. And certainly there were things like Visual Basic and Power Builder for client side things, and Visual Fox Pro and all these other things that existed and were coming up as true desktop user interface platforms. But this was one of the first attempts at having some sort of platform. In fact, let me show this on the screen here. I realized I'm not showing it. This is really an attempt to, let me see, share screen. Here we go. There it is. So there are applets in a quick nutshell. Let me just double check here. Still learning the StreamYard platform. Let's see here. Yeah, that's perfect. All right, so here's my browser, and now I can go and show you that. So that is what an applet user interface looked like. It was very flat. It was very widget oriented. I think they basically based the user interface on things like X11 windowing toolkits, concept wise. And so you had layouts for things where you would have like a grid layout or a panel border layout where you can throw things. This I think is a border layout. Throw things to the top, to the bottom, to the left and right. Was actually north, south, east, and west, and center. And then there was this thing called grid bag layout, which was this really crazy mathematically based layout of putting widgets on the screen. So let's just assume at this point that if you were trying to build user interfaces, this was crude and useful to a degree. But the biggest problem we had with applets were they were downloaded from the web onto computers of the time, of the era. So this is going to be about 1992, 3 time frame. I might be off a little bit on that. But the bottom line is your computer was a beginning Pentium. It wasn't anywhere near a gigahertz yet, hundreds of megahertz. And we're talking about low memory, low bandwidth, slow interpretation of things. And it was just an awful experience. So unfortunately, applets never really took off for anything more than engineering and exploratory purposes. But that was one of the first places that you saw Java being visible to end users. And so in that way, it got a bad rap because it was a horrible interaction between the user and the network, not necessarily because completely the fault of Java applets as a concept, but because just the technology wasn't there yet, and the concepts of good user design and the speed just wasn't there yet. And the servers to support them were primitive at the time. So you can think of Java at that era as being, primitive to a degree, and not at all something that you really would want to take on in terms of programming for professional front-end interfaces. A lot of people stuck with their Visual Basic and their other front ends for the time being, or even Visual C++ front ends for professional binaries that you would install. So that was kind of the first thing that they were used for. Now, in terms of a language, as we start talking about Java, the language, had a lot of comparisons to C. It was based on C. Let me find my Wikipedia article on C and C++. So this is a Wikipedia article comparing Java and C++. Let me share that on the screen. There we go. And so, for example, one of the things they tried to do is make Java a more friendly systems programming language to make it simpler to program than C and C++. Specifically, they tried to do away with pointer arithmetic and things like that. So I'm just going to scroll down here a little bit. If we look at a class in C++ and a class in Java, some of the syntaxes are simpler. Certainly this is a real simple example. And sorry for the comments here. Let me just make this a little smaller. For example, like you've got your class has methods, and the methods themselves are marked as public or private. So there's no section for public methods and no section for private methods. Mostly the syntax is similarly got curly braces to delineate functions and methods and classes. Constructors are a little bit different. They use this new keyword. And so the new keyword is the way of constructing things. In terms of pointers, we don't have pointers, we have references. So you don't have to remember some pointer syntax. If you create a thing and you assign it to a variable, you have a reference to that thing. So on the right here, if we have a class called foo, and we do a new, this is a variable definition of C as a type foo. If we do a new of C, we get a new foo object. And then beyond that, if I create another variable of type foo and assign it to C, I've got another reference to the object. You don't have to worry about like addresses pointing to pointers where we used to do in C. Now, a lot of people who program in C and C++ will look at this and say, yeah, well, you just didn't memorize the syntaxes. And I'm with you on that. I think I could have learned better when I was in school on C. It's just that languages that did things for client server were simplified to begin with, and I needed to be productive in my job. So I used a tool called Power Builder, and it just got rid of all those things for me for the first 6 or 7 years of my career. And I could be the nerd of the database and focus on SQL and store procedures and things like that. But as Java came out, it simplified programming for most people, and it made it a lot easier to reason about things. For example, you've got an output object with a printing function in it, instead of doing things like sending things to streams. It was a lot easier to work with. So anyway, Java as a language, its goal was to simplify syntax and make things easier to do. For example, some other things that were easier to do. were things like networking and file access. They had a nice Java Net API for writing and reading sockets and for streaming information in and out. They had pipes for networking in and out of things, and eventually for file and networking purposes, you could pipe streams of data to and from files, to and from network addresses. They eventually supported a lot of multi-threaded socket processes, so you could build servers in Java very easily. Other things that Java made easy, even back in the late 90s and early aughts, was database connectivity. One of the first APIs that I became really enamored of, and it's a simple abstraction, but the simple abstraction was JDBC. JDBC is the database connectivity library, and the database connectivity library was something that made it really easy to write code against SQL databases. You could use the same API to connect to, send statements to, get results from, and get column data from databases of all sorts, because every database implemented a JDBC driver that you would then mount a connection to. And so you just had to install the library with that driver, and you were off and running for Oracle or Sybase or SQL Server or whatever else you were using. And that was something that was out there even in like 1998, 1999, when I was first teaching Java. I actually was one of the first Sun certified Java instructors in the Philadelphia area. So I was teaching Java, and even then their training course didn't have a JDBC or a networking chapter or an IO chapter. So I wrote chapters for that early on, just because actually it was pretty easy to get your arms around these APIs and use them. So Java kind of had its second life as an applet platform, and then a third life as a general purpose programming platform that included networking and database connectivity and file I/O, and it was very useful. The other thing that it included was it had its own threading, and that went through some evolution. For example, early on, they did this thing called green threading on Windows machines and on other operating systems where the threads weren't native, so they would basically time slice their own threads, so you could run threads from a single process, and they were Java language threads. They weren't true operating system threads. Eventually, Java was able to connect in and do native threading. And eventually, we all learned that threading was really difficult to do, and we stopped writing threaded code and left that up to the experts that wrote servers for us in Java. And so, the Java servers themselves really came about early on because we had this Java networking. There were some sample file servers and sample IO servers, networking servers for sockets and so on. But one of the biggest innovations out there was Java Enterprise Edition. It used to be called J2EE. And so J2EE was really a platform for building servers and running, enterprise applications. They moved the JDBC API. They moved the Java monitoring API, I believe, but definitely the JDBC API over to Java EE. They created the servlet specification and eventually Java server pages. I remember a time where J2EE didn't even have templated server pages. You had to do all of it by yourself by writing strings in a servlet, which was just basically a way of mounting a function that responded to an endpoint. So, Java as a language was evolving. And one of the nice things about Java as a language and the Java J2EE spec was it always evolved with backward compatibility. They tried like hell to make sure that everything they did would not break when another version of Java or another version of the Java EE spec came out. And they really tried very hard to make things better as they went along. So Java as a language, originally was just all code. Then eventually they added things like little annotations at whatever to do things like injecting things into other things and to make sure that parameters are required and so on. And they added annotations in Java 1.5 or, there were big innovations there. But the language still ran the way it did in the past. So this made it very safe as a language for software engineers to use, knowing that they weren't going to be left having to rewrite all their code every time an upgrade was done. Even after Java, there are still languages out there that will break themselves as they go forward, and that's a philosophy. One philosophy is move fast and break things and improve the language, even if it's going to hurt older versions of the language. And another philosophy is, try to keep things backward compatible. Another huge innovation of Java was the whole concept of write once, run anywhere. And so the idea being that you can build a Java piece of code in the Java VM specification. So what you do is you compile this thing with a Java compiler, Java C, and it outputs bytecode. And because it outputs bytecode, that bytecode is the definition of code that runs on a fake machine, a virtual machine that they published the specification for. And when they did that, they didn't stop people from building their own languages and their own compilers that also outputted Java bytecode. And because the Java bytecode, for the most part, as far as I know, was backward compatible, you could keep improving upon your languages on top of the Java VM. So the Java VM led to languages like Groovy and, sorry, my little brain here is just shut down. Groovy, and you have things like Scala, and you have Clojure, and all sorts of like Java Ruby, JRuby, Jython, Java Python. These were all versions of languages that ran on top of the Java VM. We did projects on the Java VM for Ruby because they had access to JDBC as a library, so you could write an application back then that could use all the rich JDBC interfaces, but do it from the Ruby language. So you had the ability to write code in Ruby, which was a dynamic programming language, at the same time getting access to enterprise data sources. So it was a very innovative platform like that. It also led to functional programming languages. So for example, I had mentioned, we had Scala and also Clojure. And those languages focus more on functions than they do on objects. So you write the functions first, and you kind of use objects for data. Functional languages had a big surge probably around 2011, 2012 to now. And Java as a language is not opposed to that. Java, certainly you can write code that can run functions, and if it has to wrap it in an object to run it, it can internally. But the bottom line is you can write functional programming code, and you're still using the Java VM, all the libraries that you could write, all the work that you could do. So Java, again, 9 lives. Java as a platform, still around. Java as a language, Java language is still improving over time. And in fact, in the last 5 years, there have been major improvements to the language. We're talking about records, I think, is kind of like a bag of properties that are big now. You've got simpler iterators and walking through things functionally that are part of the language. And I don't even keep up with all those things as much, but the bottom line is they're there. And they're enabled because they've been moving the Java VM forward and adding features to the VM and features that you can implement as a language implementer, and they've been embracing that all the way through the process. If you go back and look at the Emerging Technologies for the Enterprise Conference, you can look at a number of them where we've had Java committers and Java language experts on ETE, and you can see a lot of their videos talking about where Java is heading. And that's huge, that they were really thinking forward enough to get out there in front of the public and explain what they were going to do and listen to what people in the developer community were doing. So Java has a life as a VM for dynamic and functional languages as well. Java for servers is a huge topic. Back when Java was just a language and people were experimenting with the networking APIs, and J2EE came out, there were some companies like IBM built WebSphere. There were a number of other commercial Java platforms, but there was the reference implementation of these APIs and these tools that led a lot of open source organizations to build Java servers. So for example, while people were buying things like WebSphere and people were buying BEA WebLogic to run their servers, along comes Apache. And Apache, I'm just going to go back to the old Apache project here. But the Jakarta project in Apache, which was eventually retired, and the different pieces went to their various homes in Apache, created a whole lot of infrastructure for running the web and running applications, putting aside the build infrastructure like Ant and Ivy and Maven, which Maven's repository structure, whether you love or hate Maven as a build language, enabled the usage of a ton of different libraries. They also came out with Tomcat, and so Tomcat was one of the first open source servers that did servlets the server implementation that could connect up and communicate with the world. Let me just show you the page for that while we're going through here. So, you got Apache Tomcat. Tomcat was basically an application server. It was a Java application server. Now, they didn't do all of Java EE. They didn't do the enterprise Java beans, which are like their business methods, but they figured if you needed to write code that ran on a server and you wanted to have a multi-threaded server out there that ran at a high scale, that ran logic that might go to the database with JDBC or might serve files or do whatever calculations it needed to do. You don't need all those things. The old Yagni, you ain't going to need it principle. So they came out with this simple servlet engine server that followed the Java specification for Java EE, and it followed the innovations that went along. For example, Java Server Pages, which for templating, and Java WebSocket eventually for WebSocket communication for push notifications and things like that. So there was Tomcat. And then after that, Tomcat was built. There were a bunch of other open source servers, JBoss, for example. JBoss did an entire application server, even with the EJBs, Enterprise Java Beans, and message queues and things like that. And they included Apache Tomcat as their web server for a long time. So there were a number of different innovations that the Jakarta open source team put together that were huge for Java. They really moved Java as a platform along. There were a lot of libraries like the Jakarta Commons that now is just the Apache Commons. And so they were like utilities for things like, collections management and for crypto management, for dealing with certificates and for dealing with building a CLI or creating connection pools where the connection pool is open sourced. So you don't have to license it. Just a ton of different really useful libraries. So that's another thing that was a giant innovation that now a lot of these things that were in the Jakarta page have now moved off into their own project trees as well. So, open source projects, it's a huge innovation for Java to be so embracing of open source. And it really led the way for a lot of other languages and platforms to focus on open source first. One of the other big innovations was Spring. And Spring, for us as a company, Chariot, we had based a lot of applications back in the aughts on the Spring framework. Now, the Spring framework is a framework for something called a container-based application. Now, when they say container, the idea that they put together when they built Spring was that they wanted a lightweight, logical container for code to run in that didn't require an expensive application server. It could run in a simple Java servlet server. And that means that we wouldn't have to license something or run a complex server like JBoss. We could just run Tomcat or Jetty, which was another open source project by Apache, another Java server project. We could just run a container, which was just basically a smart class in Java that would mount and find code to run. And Spring did that for us. And so Spring was an open source platform, still around. And there are many, many applications written in Spring. I would say without Spring, we would still be wrestling with a lot of boilerplate code today, even though a lot of those other libraries are around. It's just they did a whole lot for us to simplify a lot of the day-to-day logic building. For example, transactions. You could just annotate a class with @transactional, call it from a class that was operating as a servlet controller, and all of a sudden now I could do multiple things in that. And as long as I wired my Spring server up properly to pay attention to transactions, if the thing worked, it committed. If the thing didn't work, it rolled back. And it was just simple to do that. Whereas before that, you had to experiment with data sources and configuration and make sure you had the right licensing and make sure you had the databases. It was a lot of stuff. So, there were like enterprise transaction servers, but now this was just, well, if you're running Spring and you've got a data source that supports transactions, we can support that data source with transaction processing from Spring. And a lot of code that you would write just became a lot simpler. And as someone who has dealt a lot with, Java as it grew up, I can tell you that there were complex things out there that were made so much easier by Java and all the open source developers out there that focused on making Java better and giving Java a better platform to work with. Let's see here. So that's about we're 27 minutes in. Let's see what I've forgotten so far. I should mention with Spring, there was another open source framework called Seam And I remember Dan Allen from the Seam team pulling me aside and saying, "Yeah, I know you like Spring, but let me talk you through what Seam does." And at the time, they were building the Seam CLI, where you can kind of tell Seam to add features to your app, and it was really, really appealing. And it was good that those two teams were kind of competing with each other. And Seam was run by JBoss, which is now owned by Red Hat. But there was a lot of innovation on that side. They were really into creating things like better. What the heck was the name of that technology? I can't remember anymore. But the web. See, there's so many front ends that you forget about. But there were web front end technologies that were based on Java EE that we all just kind of dropped because they were complex. And they, Seam kind of took the road on that. But anyway, I'll skip that topic because I'm having a moment here. Yeah. So other things that Java EE ushered in, when they built Java, they built JMX, the Java monitoring extensions. And that made it possible for us to have dashboards that could go in and check and see how our Java servers are doing. So, for example, you now had true discovery of, is my server actually getting saturated with too many threads? Is it able to handle things properly? Or is it running out of memory? How many connections do I have? And so all that stuff led to consoles. There were consoles in BEA WebLogic, for example, where you could connect up and see how much throughput you were going through and finding out what's going on. You could even control things and bring things down and up through the JMX open extension that they had at Sun. And the interesting thing is, Sun was created as a company that was, pushing the network as the computer, and they were just a little early, and they popularized Java EE probably at their own detriment financially because the money didn't go to them always. Sure, they sold Sun Spark servers and Sun OS and things like that for the servers early on, and they had some really high-end hardware, but so did IBM and so did other companies. So they really were never able to capitalize as much on the Java EE platform. And even though they would make an enterprise server, it wasn't purchased like WebSphere or WebLogic was in the day. So they ended up being bought by Oracle. And I remember the time when Oracle bought them, I was concerned because Oracle buying something like Sun could mean, the end of the open source era for Java, but it ended up not meaning that. So that was kind of nice in that, here there was that fear of it going away and becoming some only commercial product. But there was enough of a strength in the belief of what Java represented that Oracle never really let go of it. And Oracle still fostered it. Sure, things changed. Maybe some of the licensing changed. There's certainly the commercial license for Java. But they still gave us an out in that we could still, as developers, use the open source version of Java, Open Java VM and things like that. So, I would say the platform is still running strong. It has changed because it's got a more of a profit mode of corporate-oriented company running it, but they have not stopped in any way, shape, or form the Java community for things like building Java platforms on the Java language and things like that. So that's all been very beneficial. Just as a quick note here, I'm going to go to my company's website, Chariot Solutions, and just want to show you something briefly here. And so as we're here, I'm going to say future of Java. Brian Getz. So if you search up in our, if you go and search under resources or just under the little search bar, if you search up Brian Getz, he is the Java architect. And it's not the only talk we've had over the years about Java, but if you take a look, we've got a number of discussions from him in Philly ETE 2019, Philly ETE 2016, 2014. So in the 2010s, we've had him 3 times come out, and he's the chief Java architect. And the interesting thing about him is he doesn't just come to the conference and leave. He sticks around and he talks to all the developers because he really wants to hear what people are focusing on. And that just shows you that Oracle has a commitment to Java as a platform and Java as a language that they benefit from, as well as the community benefits from, and they still see a value in that. So I encourage you to listen to the podcast, to watch the presentations that Brian Getz has, if you go and you search on, Java, if I can type Java, you can search up Java and see a ton of different talks over, oh gosh, more than 15 years. We have at least 10 years of those all available. And we have tons and tons of blog articles on Java itself as a language. So, that's kind of my initial wrap on that. Dan Mladenoff, one of our guys, says in the comments, I started learning Java 1.0 in university in 1998. Yep, that's right. And I remember at that time that was a big deal. 1.02 was my first version of Java. And so, certainly a very, very cool evolution over the years of this platform. What else? Let's see here. I guess I'm at the point now where I'm ready to embarrass myself. So let me do that. Hold on. That's right, folks. I've decided to write a song about Java because why not make a fool of yourself when you have a platform to do so? So what I'm going to do now is I'm just going to get set up for that. So give me a second or two. Oh, wrong way. There we go. I sure hope this works. And if it doesn't, I don't care. This is my podcast and screencast. Get your own. I figured I had an excuse to play guitar today. I might as well play guitar today. So just figure out the wiring here. All right, that seems safe enough. All right, so I have my trusty acoustic guitar. Let me see if I can move this out of the way. Move me out of the way. I'm inverse challenged here with the screen. You'll regret this. You might want to stop watching now. But this is, where are my notes with the song? There we go. Java the song. And yeah, this is not going to be anywhere as good as the one that we have from the Java, whatever they are. So anyway, okay, here we go. Java the song. Java, 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 Java. And the VM and the bytecode and its open source appeal. You started at a language that was meant to control TV, but everyone at the time was still trying to configure dial-up, SNP, and PPP. Java, 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 your ideas are so damn early. Controlling devices and hardware devices, we're just too squirrely. So you took a quick trip down the road to UI satisfaction, but the grid-backed layout you provided was just a painful, retargetable distraction. I just wrote this today. So you came up with Swing, and the world went to the web. Whoops! So when you say just use our servlets instead. But Java EE was a big mess, you see. It caused you to write descriptors in XML. And for developers who know, XML was a technology that tended to give off a smell. But it got better. Hold on, there's more. Hey, but Java was open. It was there for the masses. You got open source developers to get right off their asses. Apache wrote Ant and Maven and Tomcat and Jetty. And then there was Spring and Seam, let's not be petty. But the world found a new darling. It's actually as old Java. Some hate it, some love it. Its name is JavaScript, and not everything rhymes. But don't count out Java, it has so many lives. The platform hosts languages, and therein now it thrives. We got Groovy and JRuby, Scala and Clojure, Kotlin and Jython, and Haskell will even Prolog? So you see, Java is the knee of the bee. It's been around longer than a developer or three. I can't count either. So stop all your whining. It's not really declining. There's data science and caching and lots more abstracting. So put on your hip waders, because Java's gonna outlast all of the haters. Is it possible to have negative likes? I'm thinking so, but too bad. Next week, I promise I won't torture you with music, but I do want to just say thank you for watching. Make sure you like and subscribe, and make sure you keep using Java, because it's going to be around longer than we are. Cheers.